Is this page 1?
Yes.
All right. So we talked about on Friday how, like, if I am starting at the very beginning and I'm traveling to here, right? From here, start to here, that's like a 90-degree angle. So we labeled a 90 up here. And then if I go from here to here, that's 90 more. If you look at it, that's a half circle, right? And a half circle, if a full circle is a 360, well then a half circle is a 180. So this angle right here on this line is 180. And each box is 90 more. So now 180 plus 90 is 270, and 90 more puts me back, and that's a full circle. So the corners are going up by 90. It's 0, 90, plus another 90, 180, plus another 90, 270, plus another 90, 360. So what you have to do is figure out where does your angle fall in relationship to those corner angles. So 70 degrees is somewhere between 0 and 90, right? So it should fall somewhere in what we call quadrant 1. I'm going to draw it a little bit closer to 90 than I do to 0, because 70 is closer to 90 than it is to 0. And then every single one of these angles has the same starting side. This is called the initial side. It's always from the origin straight out. So that angle's always there, and then the ending side is called the terminal angle, and that's determined by this angle. So 70 degrees, if I were to have a protractor, would be like somewhere about there. Somewhere right before 90. Does that make sense? So it falls in what's called quadrant 1. On your paper, there's this thing called reference angle. We're not doing that yet. This is called the standard angle. It's angle in its standard position based on what it is. All right, so this next one says 130 degrees. Well, 130 degrees is somewhere between 90 and 180. Right, it falls somewhere in that area. So I'm going to draw a line somewhere between 90 and 180. It doesn't have to be perfect. It just has to be somewhere in that quadrant. The initial side is always the origin to the right. So like that side's always the same. This is the side that changes. So from here to here is over 90 degrees plus a little more. And that's 130 degrees. That's called the standard position. And that's somewhere in quadrant 2. Because the quadrants go in counterclockwise order. 200 degrees is somewhere between 180 and 270. Closer to 180 than 270. So like when I draw it, I try to draw it a little closer, but it's not a huge deal. Right? It's got to be somewhere between 180 and 270. That initial side is still this. So if I start, I'm going 180 degrees plus a little bit more. That's called the standard angle. And it's somewhere in quadrant 3. And then 300 degrees is somewhere between 270 and 360. So I'm going to draw some angle down here in quadrant 4. And then the standard angle has a starting side like this. It's not this angle here. It's like almost all the way around. That's the standard angle. Almost a full 360, but not quite. 60 more to go. Does that make sense? That's called standard angles. Today what we're going to do is take standard angles and find these new angles called reference angles. And this is where the trig actually comes in. When I think trig, I think sine, cosine, tangent, right? That's like the heart of trigonometry. In order to use sine, cosine, and tangent, you need right triangles, right? That's where they come in. So we have an opposite side, we have a hypotenuse. So I need to take this image and create a right triangle out of it, so that I can use sine, cosine, and tangent. When you create the right triangle, it's called a reference triangle. It's what we're going to refer to when we solve for things. So it's a reference triangle. So we're going to take these images and create a right triangle, which is called a reference triangle, and we can use that triangle to solve for missing side lengths. We can use sine, cosine, and tangent to do that, all right? So, reference triangles. Everything I just... So here we go. I'm taking the images that you just had. All of that is 11, 12, 13, and 14. Now you see it here. And I want to create a reference triangle. The key to a reference triangle is that it's created with the terminal side. So the terminal side is the ending side. Right? So you'll see that all of them have this same starting side. The reference triangle is always with the ending side. So the reference triangle is created with the ending side, And it's also created with the x-axis. Sometimes it gets confusing and you're going to want to do it with the y-axis, but we always want to use the x-axis. So what that means in terms of each of these. If the terminal side is in quadrant 1, then I'm going to use the x-axis on the quadrant 1 side, which is this line. If the terminal angle is in quadrant 2, I want to use the x-axis on that side. So I'm actually not going to use the initial side at all. I'm going to use the x-axis, but I need to use the x-axis in quadrant 2. So the x-axis in quadrant 2 is this one. Everybody okay so far? So if I'm in quadrant 3, like this one is, I need to use the x-axis on the quadrant 3 side. This initial side is on the quadrant 1 and 4 side, so I'm not going to use that. The x-axis I'm going to use is the quadrant 3 x-axis. And then finally, in 300, if I'm in quadrant 4, then I'm going to use the x-axis on this side. So the key is you're using the x-axis to create this triangle, and it's got to be the x-axis on the side of the ending angle, not the starting one. And then the last thing we do is we create a perpendicular line dropped from this. So if I want to create the triangle, I need to create a third leg. So I'm just going to drop this straight down. I'm just going to drop this straight down. I'm connecting the red to the blue with a straight line. So wherever red and blue are, I'll just drop down a straight line. And now I have right triangles. That's called the reference triangle. So the reference triangle is created with your ending angle, which is called your terminal side. The x-axis, and sometimes we'll use the x-axis on the left, and sometimes we'll use the x-axis on the right. It depends on where your angle is. If your angle is in quadrants 1 or 4, we'll use the x-axis on the right. If your terminal side or your x-axis is in 2 or 3, we'll use the one on the left. And then finally, the last side length is just a straight leg of a triangle, and it's connecting the terminal side to the x-axis. So it's just a straight drop down. All of these are called the reference triangle. We okay so far? We know that the standard angle is from the start to the red line. So for all of these, we know that red angle. That's what we graphed. All right, so the red line is called the standard angle. So the 70 degree is my red line. That's my standard angle. What we're looking to find is called a reference angle. The reference angle is inside of the triangle. Sometimes the standard angle is inside of the triangle, and you can see sometimes it's not. Like it's inside, my red line is inside of the triangle for number 11, but it's not inside of the triangle for number 12. You see how the arrow's outside of the triangle for number 12? It's inside of the triangle for number 13, but it's not inside the triangle for number 14. All right, so the standard angle may or may not be in your reference triangle. Your reference angle is always inside of the triangle. So your reference angle, I'll do this one in purple. Your reference angle is going to be the angle in the corner of the triangle. So at the origin, whatever angle is touching the origin. That's your reference triangle. So for this one, here's the origin. The reference angle is the one inside on the corner. So here's the origin. The reference angle is inside. Here's the origin.
So for 70, is it just 70 again?
It is. But you'll see that it's going to be a different rule for every quadrant. All right, so the reference angle is the purple one. I'm actually going to change the color so you can see it a little better. Maybe people it might show up a little better. So the reference angle is always inside of the reference triangle, and it's going to be the corner angle. It's gonna be the one touching the origin, which is your 0, 0. So this pink angle that I'm darkening is what's called your reference angle. And visually, we're gonna be able to figure it out. Now, if you're not a visual learner, eventually there's gonna be rules for each quadrant and you can memorize the rules. But you can see it too. So like Will said, you can see like this red line here is tracing the same image as the pink is. So like red is here to here, and pink is here to here. That's the same thing. So the reference angle is the same as the standard angle if you're in quadrant 1, okay? So if my standard angle is 70, then my reference angle is also 70. That works for that one. But you can see red here, which is this is 130 degrees. That's not the same as the pink angle. The pink angle is definitely not 130 degrees. The pink angle is definitely acute, right? It's less than 90. It's a little angle in the corner. Well, let's think about what we know. What's from here to here?
180.
180, right? So together, the red and the pink meet to make 180. Do you see that? So then can we figure out what the pink is? If I know the red is 130 and I gotta go to get to 180, how much further do I need to go? 50. All right, so in this quadrant, I know that my reference angle, we'll call that R, and my standard angle together form this half circle. So I know together they're going to equal 180. So if I know one, then I can get the other by subtracting it from 180. So this one's going to be 50. That's different than it was before. So you just have to really look at the picture. Well, if I'm looking at number 13, my standard angle is this red. So it's 180, and then it goes 20 more, right? So the red angle, the standard angle is 180, and then 20 more gets me to 200. Well, the 20 more is the pink. You see that? So it's 180 plus pink equals that big angle. So what do you think that is? 180 plus 20 more. That extra 20 is my reference angle. It's that little angle, which is different than what I did here. Here it's like 180 plus the reference angle is giving me that big angle, that big standard angle. So again, eventually we're going to write down rules, but right now we're just doing it visually. So let's look at the last one. The red angle is called the standard angle. It's almost a full circle. The pink angle completes the circle, right? Together, red plus pink, if I were to connect that, is a full circle. Well, a full circle is 360. So if the red is 300, what's the pink got to be? 60 more. So the reference angle is 60. You can see it, right? The hardest one, I think, to see is the quadrant 3 one, because they're overlapping. I think the other ones are pretty straightforward. We okay with that? So we've got standard angles. They're going to be graphed based on like the corner angles of a triangle. And then we've got reference triangles. We're going to create this triangle. We're going to work through a rule, and we're going to find it. All right, so let's have you practice some. All right, so in your workbooks on page 16. I think these have pages, right? Page 16. You're going to try 1 through 4. Number 4 is kind of tricky. We talked about number 4 on Friday. Let's just see what you remember about that. If you don't remember, that's okay. It's that one, yeah. So page 16, you're going to try 1 through 4. So it gives you the standard angle, right? You're going to graph that. And then from there, you're going to create the reference triangle to find the reference angle. Remember, the reference triangle is created with the standard angle the x-axis, depending on which side you are, it might be the left x-axis, it might be the right x-axis, and then you're gonna drop a straight line. So page 16 has, I'll show you the angles.
Wait, how do you get a 635 degrees? So can you just
So
keep going
sub-
around?
So subtract 360,
Okay.
and you're gonna be right back where you started. You know what I mean? Or sorry, this isn't workbook, this is workbook. So workbook, oh, did I not give you these?
I don't think you.
I don't think I did either. You guys gotta grab one, sorry. So workbook, page 16, 1 through 4. So 1, you're gonna graph 200 degrees, and then find the reference angle after you graph it. 2, 30 degrees. Four, 6, 3. What's that? Sure.
Keep getting a phone call from the same number and it says bail bond.
Uh-oh.
Bail bond. I'm scared I forgot to go record. They've called me 6 times.
Well, go answer it.
No.
You don't wanna know.
No.
Wait, you answered on speaker.
No. It says like bail bonds on the bottom. Like look. The bonds bail. No, it's because I don't pay any of my tickets. And when I had
Well, that's
12.
not a smart decision.
I had 12 outstanding parking tickets in Philly, and I had a warrant out for
How
my
do you
arrest
not
like
learn?
2 months ago.
How do you get 12 tickets and not change
How? So I was like staying at a buddy's house in Philly, and like
We're already
tickets
not turning
started-
over a new leaf.
And like tickets started like piling up. on
This
my
is not a
house.
good sign.
And I
The
think
new leaf would be like, I'm gonna graph this reference triangle.
I
I'm
already
gonna
did.
find this
I'm just
standard
confused,
angle.
like, I got one parking ticket and I was traumatized, so I changed how I park.
I forget to pay everything, and then the bail bondsman starts calling me, and then like I get like a mandatory court date that I forget to go to if I get like a speeding ticket. Oh my gosh, last time I forgot to
You
go to
really
the
got a
court
parking
date.
ticket in Chestnut Hill.
My
Yeah.
mom
And then
was
the
so
next weekend I
mad.
got one in Chestnut Hill, and then I changed Chestnut Hill.
But it tells you it's
My
bail
parents would tell me if I
bonds,
got 12.
like your phone does.
My parents would stop at
You got too much
the
free
store.
time.
It says bonds bail.
I believe you.
On the bottom.
They're out for you.
They're gonna be at my house.
Yo, there's a problem. Yo, there's something wrong. There's something wrong.
What?
There's a warrant out for you.
There's been
For
multiple.
something really bad though.
Pennsylvania man caught 3,000.
Alright, I'm not saying we're solving this, right? But can someone tell me at least what quadrant am I in if my standard angle is 200 degrees? Alright, we're in quadrant 3. Alright, what quadrant am I in if my standard angle is 30 degrees? 1, okay, we're doing good here. Alright, what about 350? Alright, now the next one, so this is the standard position. This is what we went over on Friday. Now the next one's a little bit trickier. We talked about this on Friday, but it was at the end of class and some of you were still quizzing. We said that if it's above 360, we gotta do what? Does anyone remember? Minus 360. So if we subtract 360 from this, did anybody do that? What do we get?
You get, well, I just got the reference angle.
What is
It was like
that?
270.
275, all right. So this is really the angle you're graphing. 635 and 275 are the same exact angle. One is just an extra rotation around. So what quadrant am I in if I'm graphing 275? We're in barely in 4, but yes, we are in 4. So this angle is somewhere here, right? That's all called the standard angle. Then we have to create what's called the reference triangle, because this image for number 1 is on the left-hand quadrant. We're going to use the left-hand x-axis. And we're going to drop it straight down. That's what the reference triangle looks like. We okay with that part? So we want to know what this angle is. That's what I want to know. That's called the reference angle. What I know is this. So I know what I want plus 180. So what I have is 180, a half circle, plus what I'm trying to find. So what's the pink angle? 20. 180, 20 more. So that's 20. We okay with that one? All right, let's look at the next one. I have this angle, it's in quadrant 2 because it's, quadrant 1. Since it's in quadrant 1, since it's on the right-hand side of my graph, I'm going to use the right-hand x-axis as my bottom line. And then I'll drop. This angle in the corner is what I want to know. That angle is called the reference angle. This angle right here is what I do know. So what's the reference angle? 30. It's the same. In quadrant 1, it's the same. The red is the same as the pink. So the reference angle is 30. All right? In quadrant 4, because this angle is on the right-hand side, I'm going to use the right-hand x-axis, and I'm going to drop this straight down. So like that third leg connects the blue to the red. And this angle right here is what I'm looking for. But this angle's what I know. What I know plus what I'm looking for is a circle. So what's the pink? 10. It's just 10 more of the way. So the reference angle is 10. All right, and then the last one, because this image is on the right-hand side, I'm going to use the right-hand x-axis, and I'll drop this here. So this is what I want to know. This is what I know. So what I want to know plus what I know is a full circle. So what's the reference angle? 85. The rest of the way, right? The full circle. 85 plus 275 gives me my full circle. What do we think? All right. If you're good at visually doing things, like you could see that, you can make that triangle every time and use a visual. If you're having a hard time creating the triangle or seeing what the pink angle is, there's just rules you can follow, right? Each quadrant has its own rule. So in your notes, there's a section that has this box, reference angle rules, all right? So the quadrant 1 rule is that it's always going to be the same, all right? In your toolkit, is there this box on the next page maybe?
Yeah.
All right. So we're going to do the degree mode side. Every angle we've graphed so far has been in degrees. So we're going to stick to the degrees. Eventually we're going to graph in radians. But for right now, quadrant 1, that reference angle we were looking for was equal to the standard angle. Okay, so if you look at my picture, the blue angle was the reference and the red angle was the standard. They're the same thing. In quadrant 2, the red angle, which is my standard, plus the blue angle, which is my reference, together those two angles created a half circle. So if I were to connect my red and my blue all the way through, you'd be looking at a semicircle. So together they create an 180-degree angle. We okay with that? I'm gonna skip to quadrant 4. Again, quadrant 3 is kind of the trickiest one, so I'm gonna go to quadrant 4 just because it's a little more visual. In quadrant 4, my standard angle, so my red plus my blue, if I were to connect all the way through, red and blue make this full circle together. So my reference plus my standard equals 360. Together, those two angles equal 360, a full circle. All right, so in quadrant 3, I'm going to take my standard angle, which is my red angle. That's the big angle. And I'm going to subtract the half circle. The big red angle minus the half circle will give me the blue angle, which is my reference angle. We could rework any of the rules that I just did. We could solve them for R and make them like reference angle equals, standard angle equals, right? We could rework them if we wanted to, but this is like the general rules. I'm only going to use these rules if I'm a person who doesn't see the triangle, right? If you can see the triangle, you don't have to memorize rules. If you can't see the triangle, then the rules work every time too. We okay with that? All right. So there's this other side that says radian mode. We got a graph in radian mode too, okay? It's definitely harder. You learned how to change degrees to radians. Well, some of you did. Some of you left that blank on your quiz. But some of you learned how to change degrees to radians. We learned that 180 degrees is the same thing as pi radians, so we could make that conversion. So these are the angles that I know how to graph. They're the corner angles. So I need to change 90 to radians. So here's what we do. Well, 0 is obviously just 0. All right, so 0 is the same as 0 pi.
Where are we putting this?
It is not in your book, but we are going to go back to this eventually. You're not writing this down, but we're going to go back to the beginning. All right. So let's figure out what 90 degrees is. So here is how you do a 90-degree conversion. It's not in your book. You don't have to write it down. All right. So 90 degrees. When I do conversions, we multiply by fractions. And what I want to make sure is that, because I don't want degrees, I want the degrees to go the opposite spot. So I want degrees down here. And the degree I know is 180. And that's equivalent to pi. And then we can make this a fraction. And we multiply straight across. 90 times pi over 180. And the degrees cancel out. Well, what's 90 over 180? Pi over 2. 1/2. So on your image that you have in the very beginning of your toolkit, there's this graph that we have that looks like this. We wrote 90 degrees right here. You're also going to write pi over 2. They are the same exact angle. They are in 2 different units. That's like me telling you 3 feet and 36 inches. That is the same measurement, right? It is in just a different unit. So 90 degrees and pi over 2 are the same angle. So at the very beginning of your toolkit, we did this graph. You're going to write next to the 90 pi over 2. Well, let's think about 180. So if I have 180 degrees, and I want to change it to radians, I want to make the degrees cancel out. So I'll put the 180 in an opposite spot. And I multiply straight across. 180 pi over 180. Well, what happens there? So we know that this angle is 180 degrees. But now we also know that it's pi in radians. Think about what's happening here. 0 to 1/2. 1/2 to 1. What do you think this one is? Plus 1/2 plus 1/2. What's 1 plus 1/2? You're thinking 1.5,
Yeah.
right?
Yeah.
What's 1.5 as a fraction? An improper fraction. 3 over 2, right? So this is 3 pi over 2. Or 1.5 pi is fine with me. You can write it as 1.5 pi. In fact, that might be easier for you to see, all right? All right, so if I'm adding 1/2, what's 1.5 plus 1/2? 2, so 270 is the same thing as 3 pi over 2, and 360 is the same as 2 pi. All right, we could do the conversions, but really you're just adding 1/2. It's 1/2 pi, 1 pi. 1.5 pi, 2 pi. It's just the halves, all right? So in this image, quadrant 1, quadrant 2, quadrant 3, quadrant 4, this is the 0, 360, that's your pi over 2, that's your pi, and that's your 3 pi over 2. So I'm just changing the degrees to radians here, all right? So now we're going to graph one. Pi over 4. All right. Let's change pi over 4 like Colin you were doing. Let's change it to a decimal. What is 1/4 as a decimal? If you don't know, type in your calculator. 1 divided by 4. 0.25. So pi over 4 is the same as 0.25 pi. I'm not changing anything. I'm just making 1/4 a decimal. Is this not on your toolkit? Some of you are looking.
That's not what it's.
I see it. It's number 7. Yeah. All right. So tell me if you lost my train of thought if I'm saying that pi over 4 is the same thing as 0.25 pi. Are we okay with that? All right. And so instead of me looking at this as pi over 2, I'm going to look at it as 0.5 pi. 1 pi. 3 over 2 is 1.5 pi. And 2 pi. Ignore the pi. Look at the decimal. What decimal does 0.25 fall in? Does it fall between 0 and 0.5? Between 0.5 and 1? Between 1 and 1.5? Or between 1.5 and 2? It's between 0 and 0.5, so ignore the pi. You don't have to worry about it. Look at the decimal. 0.25 is somewhere between 0 and 1/2. So I'm going to graph this somewhere in quadrant 1. I don't care where. Okay, just draw a line somewhere in quadrant 1. We okay with that? Let's not talk reference angle. Let's just talk getting them on the paper. All right? All right, let's look at number 8. 5 pi over 6. Well, let's figure out what 5/6 is as a decimal. Type 5 divided by 6 into your calculator. Tell me what it is as a decimal. What is it? 0.83-ish? It's a lot of decimals, right? It's like 0.83333333. All right, so 0.83 pi.
I swap my calculator
Yep.
to charge.
Yep, there's one. Okay. So, all right, I'm trying to figure out then where does 0.8383 fall on the realms of these decimals. So this is 1, this is 1.5, this is 2. Well, 0.83 is somewhere between 1/2 and 1, right? So then 5 pi over 6 is somewhere between pi over 2 and pi. So I'm going to draw something in quadrant 2. I don't care where you draw it, right? We're just looking at decimals here. The pi is just coming along for the ride. This angle is somewhere in quadrant 2. Are we okay with that? All right. What about 11 pi over 6? Type 11 divided by 6 in your calculator. It's like 1 point something. What is it? 1.83. So it's 1.83 pi. Well, 1.8 is somewhere between 1.5 and 2, right? So this is somewhere in quadrant 4. And I'm just looking at decimals here. So if 1.8 is between 1.5 and 2, what that ultimately says is that 11 pi over 6 is somewhere between 3 pi over 2 and 2 pi. I'm just using the decimal form because it's easier. All right, let's look at 4/3. 4/3 is 1 1/3. So 1.33 pi. So if this is going up by 1/2, so that's just 1. What quadrant is 1.3 gonna go in?
30.
There is another way. You could change the angle to degrees. And then graph it in degrees, right? It's gonna be a lot of work, because you're gonna eventually have to change it back to radians to find the reference angle. So you could do the whole problem in degrees and then convert back at the end. I think working with the decimals is faster, it's shorter, but you can do it. Like, it is possible to just switch it to degrees. Multiply by 180 over pi, change it, and an alternative, all right? So my ending practice for you is gonna be, I want you to try to graph 15, 16, 17, and 18 on your toolkit. You're just graphing the standard angle. See if you can figure out what quadrant they fall in. Are those the same ones? They're not, right?
No.
All right, so I think the number 17 is the same one, but the rest look different. All right, so try to graph them, see what quadrant they fall in.
Can I spare my
Yeah. Yes.
We're not doing the reference angle yet?
You can try it.
Is it just like,
It's just instead of using 180, you would use pi, because 180 is pi. Instead of using 360, you would use 2 pi. You could probably figure it out. It's just when you're doing the math in your calculator, you're not gonna put pi in your calculator, because pi's irrational and it'll need to have long decimals.
yeah, so this would just be the
Quadrant would
reference
be the
angle.
same,
yeah.
yep. If you look at those rules that are written,
Yeah.
you can use them.
Wait, did we get the radian rules?
We didn't do the radian rules. The radian rules are the same though, it's just everywhere there's a 180,
Yeah.
it's pi. And everywhere there's a 360, it's 2 pi.
Yeah. And we're not allowed to, we have to put it in standard form, not like decimal form for referencing.
Yes, so unless if it's not a repeating decimal, I'm okay with it.
What do you mean?
Like if it was like, I don't know, 1/10 pi, 0.1 pi is fine.
Yeah.
But if it's like 2/3 pi, you get 2.67 pi, because that's not the same thing.
Yeah. Okay.
All right, do we know what quadrant number 15 falls in? Pi over 6. 1? Is everybody okay with 1? 1/6 is some decimal between 0 and 1/2. So I'm going to draw something in quadrant 1. What about 5/6?
It's in quadrant 2.
It's in quadrant 2. 5/6 is more than a half, because 3/6 is a half, but it's less than 1, because 6/6 is 1. So it's somewhere in quadrant 2.
I have a question.
Sure.
So for that one, would it be like as easy as saying like it's just pi over 6? Because you're just minusing.
We'll go with
yeah.
one more. Yep.
You're
The
basically-
reference angle is pi over 6 for
It's
that one.
180, so you're just minusing 5 off 6, then you have 1 over 6.
Correct.
Yeah.
Yep. Quadrant 3 is really the only one that's tricky, I think. I think it's semi-easy to figure out other than that. All right, so this one we did already, I think. We said that one's quadrant 3. That's the same as one of the first examples. All right, what about 7 pi over 4? Is that quadrant 4? So we're looking at 1 3/4. So 1.75 is bigger than 1.5. We okay with that? From here, creating the reference triangle should be easy. I don't want to say easy, but it's the same, right? So I'm going to go the x-axis, and since this is on the right side, I'll use the x-axis on the right side. And then you connect the red and the blue with that straight line. That's the reference triangle. For this one, since the reference angle, or the angle's on the left side, I'll use the left x-axis and I'll drop straight down. That's the reference triangle. This one, number 3, this is on the left-hand side, so I'll use the left x-axis and drop that down. And then the last one is on the right-hand side, so I'll use this x-axis and drop that down. So creating the reference triangle is not any different in degrees than it is radians. The actual triangle itself is the same. The actual angle itself is that corner angle with the origin. So like this is the reference angle, this is the reference angle, this is the reference angle. The only problem is the actual math behind it is a little bit trickier because you're working with pi. All right, so in quadrant 1, the pink angle, so if the red angle is there and the pink angle is there, they're the same. So in quadrant 1, we said that rule on your paper is that the reference angle is the same as the standard angle. That's still true in degrees. So if the standard angle is pi over 6, then the reference angle is pi over 6. That's not any different. Right? They're the same in quadrant 1. In quadrant 2, we said that the standard angle plus the pink angle, so red plus pink, R plus S, is equal to a half circle, which is 180. We okay with that? Together, this plus this is 180. The problem is we are no longer in degrees, so that 180 has to be a radian. What do we know about radians? 180 degrees is equal to how many radians? That's that one rule you had to remember for your quiz. 180 equals pi. Okay, so I'm going to change the 180. Actually, we'll keep it on there. I'm going to change it to a pi because 180 degrees is pi radians. Together they're a half circle, but a half circle is 180, but it's also pi. They're the same thing. 36 inches, 3 feet, same thing. Different units. 180, pi, same thing, different units. So here's what I have. I have a standard angle of 5 pi over 6. I need to figure out 5/6 plus what equals 1. Ignore the pi. Solve the equation. If I wanted to get R by itself, what would I do to this? If I wanted to move this to the other side, what would I do? Subtract. Ignore the pi. In your calculator, do 1 minus 5/6. Ignore the pi. 1 minus 5/6. Math, enter, enter. The calculator will give you the fraction. 1/6, right? We ignored the pi, then bring it back. The pi just goes on the top. So my reference angle is pi over 6. I don't have to do common denominators and all that fancy stuff. Just ignore the pi, let the numbers do the math, and then the calculator will change it to a fraction for you. 1 minus 5/6 is 1/6. So 5 pi over 6 minus pi, or pi minus 5 pi over 6 is pi over 6. All right, I'm going to skip this one for right now. I'm going here. Last one. All right. If I know that together red plus pink make the full circle, right? Red plus pink is a full circle. I know that red plus pink is a full circle. But I'm not in degree mode anymore. I'm in radian mode. 360 is how many radians? So it's 2 pi. So here's what I know. Reference plus 7 pi over 4 equals 2 pi. Ignore the pi. Solve the equation without the pi. So R plus 7/4 equals 2. How do I solve that equation? How do I get R alone? I subtract 7/4. So in your calculator, do 2 minus 7/4. Math, enter, enter. What do we get? Is it 1/4? 1/4? So if it's 1/4, then what that means for my fraction is it's not 1/4, it's pi over 4. I just bring the pi back. It's kind of trickier in radians, I get that, all right? So when you come in tomorrow, haven't done this yet, and I feel like maybe this is where I'm faulting myself. I'm going to give you something as a warm-up to turn in so I can check in with you. We're going to interact more. We're both turning over a new leaf. Okay, so I can see where we're at with reference angles and triangles before we move on and when we can address things.
Did you give the 1 for 3?
I didn't, but
I said 0.3 repeating for nickel.
it's pi over 3.
Yeah.
The reference angle is pi over 3. All right? All right, so tomorrow when we come in, we'll practice that for the first 15 or so minutes to make sure we're okay before we move on.